We did sequences so far. Justin, what's a sequence? What's a sequence? Now you have to pay very close attention. These are like tongue twisters. What is a sequence? That's all we've done. Did sequences in 8-1.
What is that a question?
Yeah, what is a sequence? Anybody know? Okay, list of numbers in a definite order. Okay, you guys. So, if I have a sub n, that sequence would be a sub 1, a sub 2, a sub 3, a sub 4, and it would go on to a sub n. Just a list. Well, what we can do with this list is we can add up the terms in the list. And that's called a series. So now you have sequence and series. See what I'm saying about tongue twisters? Easy to mix them up. So if I add up all the terms in my sequence, I would just put a plus sign between all the terms. I don't like that. So it's A1 plus A2 plus A3 plus AN, and then it continues to go on. Now, we need to know about sigma. So we're going to be doing a lot of stuff with sigma. And we can write this, and that just means the sum of all the terms. The bottom number, this n equals 1, is where we're going to start, and we're going to go off to infinity. And I wanted a sub n, and it's a counter. So n is going to be 1, then n is going to be 2, then n is going to be 3. Is that okay? With the sigma? Okay. We're not going to do a lot with partial sums, but what I could do is find the sum of the first one term. That would be A1. I could find the sum of the first two terms. That would be A1 plus A2. I could find the sum of the first three terms. These are called partial sums. Not adding up all the terms in the sequence, but only the first three. And I could do S sub 4. And you know what else you could do with this? This is what drives you kind of nuts, is each of these sums, I could make a sequence of the partial sums. I know, that's what I said. It's like all these tongue twisters. But you know, if this is, wait, maybe we should just make we could make a simple example. Let's go down, I just need a space. No, let's make it a really easy sequence. My website. A sub n is equal to 1, 2, 3, 4, 5. Okay? No, it's just a list. I'm not adding them. Not necessarily. So what's S1? It's equal to A1, which is equal to 1. Then what's S2? It's A1 plus A2, which is equal to 1 plus 2, or 3. S sub 3 is A1 plus A2 plus A3, and that's equal to 6. Let's do one more. S sub 4, A1 plus A4 is equal to the preceding one. You could do it recursively. It's the one before plus the 4. Well, I don't know if I can do that. So it's 10. Okay, what is the sequence of partial sums then? So this would be S sub n. That's how you write it. Well, that would be 1, 3, 6, 10. What's the next one going to be? 10 plus 5 is 15, etc. Okay, so I've mixed series with a sequence. And even if you wanted to do that, you could have the sequence of the partial sums. Okay, I don't want to go there. Okay. Oh, we'll get lots of applications of this. Hang in there. Okay. Will we do much with partial sums? No. Now, if, you guys, if my sequence of partial sums is equal to S, then we have the sum of the infinite. I think I'm saying that wrong. There it is, A1, A1 plus A2, etc. And if the limit of my S sub n is equal to S exists, then then we have the sum of the infinite series. Very hard to find the sum of an infinite series. So just in general, and sorry the page numbers are wrong because it's out of the old book and I didn't fix that. If I see this, sigma A sub n, it's really taking A sub I is going to go from 1 to n and taking the limit as n goes to infinity. You will think of this automatically. You won't even think of this limiting thing. You'll just think this way. It just means we're going to go to forever. That's all. Nothing really big to worry about. Okay, this is the most important series of them all. That's why there are 4 stars on my slide. These are geometric series. Let's do an example of a geometric series. An easy example. You have 2 plus 4 plus 8 plus 16 plus 32. I am multiplying by a constant to get to the next term that I'm going to add in there. What am I multiplying by? 2. Hope I did it right. That's times 2. You can multiply by anything you want. But that's what a geometric series is. Can you write this as an exponential? Can we write it as a summation? It's 2 to the n starting with where? 1, and we're going to go off to infinity. So when you see an exponential function, it's a geometric series. Have you had that in multivariable? Okay. So this is exponential, not a power. You're going to see tons of sigmas. You know, n squared, that's a power. That's an exponential. And that's going to be geometric. Well, I'm going to prove what the sum of this is. Can I change my background? No, I don't like the background. Okay, so I'm going to take this down. I want, now, A is your starting number, and you're going to multiply by a constant ratio, a constant value. Could be 2, could be 3, could be a third. And then I'm going to multiply this one by R. And this one by R. And this is how it looks if you start at 1. It looks different if I have a different starting value. Because I want this to be a to the 0, which is why this is n minus 1. Another way to do it is to start with n equals 0, and then go off to infinity. That doesn't matter. Then it's AR to the n. Check. If n is 0, what's r to the 0? 1. If n is 1, then it's AR to the first. You see the exponential here. By the way, does it look kind of familiar? We had an r to the n in section A1. And it's going to come into play here. Okay, so I'm going to rewrite this. Well, maybe right here. I want to find out what the sum of the first n terms will be. So S sub n, and this is going to be a math trick, is equal to A plus AR plus AR squared plus AR cubed, and it's AR to the n. What I'm going to do is multiply this equation here by R. I'm going to prove a formula, and you're just going to know the formula. You don't have to prove it. So I'm going to take R times S sub n. And so if I multiply by R, then this is going to be AR. Let me line it up under AR, because it's the same type of thing. Are you okay with the fact that I lined it up? And then I'm going to multiply this one, AR by R. What am I going to get? AR squared. Okay, Justin? What am I going to get next? Multiply by R, I'm going to get AR cubed. And when I multiply the one before this, I'm going to get AR to the N, and then I'm going to get AR to the what? N plus 1, right? Now, what I'm going to do with this is I'm going to subtract the bottom equation from the top equation. Why would I do that? Because what's going to happen when I subtract all these middle things? They're going to go away. That's right. Now, this is a well-known formula that we're going to come into, and that gives you the sum of the first n terms. I want to know what all the terms add up to. So when I subtract, I get, I guess I can write this here, S sub n minus R S sub n equals, nice. I get A, and all of these guys do what? They go away. I love it. Don't forget there's a minus, I couldn't hardly see it. Minus A R to the n plus 1. A lot of letters. My calculus class said they liked it better when there weren't so many alphabetic letters there. I'm going, because you're going to add the opposite. Well, it's AR minus AR. It's a math trick. And as you do more math, you learn more tricks. And then, when you get something that nobody's seen, you apply all those tricks to figure out what's happening, if it works. You know what I'm going to do? I'm going to factor out S sub n. I'm left with 1 minus R. Can I factor an A out of this? Equals A, and it's 1 minus R to the n plus 1. Oops. Solving for S sub n, I'm going to get A, 1 minus R to the n plus 1, divided by 1 minus R. So if I asked you to add up the first 100 terms of that, 2 times 2 times 2, I could do it. Let's do that. We had 2 plus 4, and I find it easier probably just to list them out than to use the sigma notation, but that's up to you. So what's my starting value? What's A equal to? 2. What's my common ratio? I'm multiplying by 2, and I'd like to find the sum of the first 100 terms. So I'm going to substitute it in my little formula. So it's 2, and it's 1 minus 2 to the what power? No, it's n plus 1. 100 terms. 101 over 1 minus 2. And that would be what the answer would be. Is the answer positive or negative? On the top, you mean?
No, like when you're subtracting.
Oh, I did the right-hand side. I get A still is left, that didn't cancel out, and this didn't cancel out.
What? Why did you?
It was a trick.
So I said minus R is
Pardon?
So that
I just multiplied by R and subtracted, and all the middle stuff goes away. Trying to find S sub n.
Oh, you said S sub n minus R.
I factored out S sub n.
Oh, okay, got it.
Factor out A. Because what I did was, like I said, it's a trick. I took R times, it says right, multiply R times S. I did. I took R times this, R times that, but I lined it up. And R times this would be AR squared, but I lined it up. Didn't have to line up, it was easier to see. Subtracted it. Yes, just shift it over a little bit. Okay. So, is it positive or negative, by the way? It should be positive. Is it positive? 1 minus 2 to the 101, that's a negative number. 1 minus 2 is negative. So, yeah, it's positive. Okay. Now, does this sum, if I add up the terms in my sequence, Justin, could it possibly converge? Could you possibly have the sum of the elements of a sequence actually add up to a finite number? So let's find out. Is that on the next slide or is that in the same place? Okay. I would like to find the limit of S sub n. I'm going to see if it's here. That's the answer. Whoa. Okay, so I'm going to take this S sub n equals a 1 minus r to the n plus 1 over 1 minus r. You know what I'm going to do? I'm going to take the limit and let n go to infinity. Are there any r values for which that will converge? Remember, we did the limit of this. Justin? Were there any values where this is actually convergent? And you remember what r had to be between? So it was absolute value. R had to be between 1 and negative 1, actually included 1. That was for the sequence. So let's take the limit of this. Doing the problems is way faster than this, but it's kind of nice to see where the formula comes from. Let's let n go to infinity. And it's the limit as n goes to infinity. So the limit as n goes to infinity of S sub n is equal to this. I have to clean it up because it's kind of a mess. Now, does that limit affect this a over 1 minus r? Are there any n's in the a over 1 minus r? But just in this piece right here, are there any n's there? No. So I may pull that right out of the limit. It's a number. It's a constant. It's whatever it is. So I'm going to get the limit as n goes to infinity of S sub n is equal to a over 1 minus r times the limit of this thing as n goes to infinity. Well, that's looking better. Better and better. Can I take the limit through that parentheses? Yeah, I can. So the limit as n goes to infinity, S sub n is equal to 1 minus a over 1 minus r, and it's times the limit of 1. What's the limit of 1? 1 minus the limit as n goes to infinity of r to the n plus 1. So I think I want r to the n. I don't think it really matters. Okay, what do I want? I want to pick r values so that this goes away. When will that converge? We just did that. We just talked about it up here. R has to be what kind of number? A fraction, doesn't it? Yeah. It has to be 1/2. I don't care if it's n plus 1. So r must be between 1 and negative 1. We already know negative 1 doesn't work, so we did that. What if r is equal to 1? We have a little problem. If r is equal to 1, even though the sequence up here converges at 1, what happens on this limit? We're going to call this s is equal to a over 1 minus r. And if r is equal to 1, then I get 1 minus 1. And r is equal to 1. I'm going to get a 0 there. I'm going to get a 0 there. And can we have that happen? No. We don't know what 0 over 0 is. It's indeterminate. So guess what? We can't include 1 in the series. You can in the sequence, but not in the series. This is a geometric series, and they will always converge, provided that their common ratio is between 1 and negative 1. And there are many problems on the multiple choice part of the exam that requires you to do this. There's only 2 types of problems where you can actually find the limit of a series. You actually find the value. One is a geometric one. The other one we're going to do tomorrow, and most likely they will never ask you that. So the minute they ask you to find the value of a infinite series, it has to be geometric. You might want to write that down. Like, I'll write it down right here. If you are asked, put a big star there when you review for your quiz and test in this chapter. If you are asked for the value of an infinite series, the other one I don't even think you're to see. It will be geometric. So there's a clue. Because you won't recognize it as geometric. So what you do is you write out some of the terms. And the sum for a geometric series is a over 1 minus r, provided that the absolute value of r is less than 1. And I think I better do this. I always forget what it's going to do. There it is. Really, really important. And it's easy once you catch on. I think we're ready to do some problems. Now, you won't remember where the formula comes from, but at least you've seen it. And at least you're motivated, hopefully, to see why r has to be between 1 and negative 1. You've seen it for a moment. This is water with orange juice. I don't like plain water. Okay, here's the geometric series. When in the book, when they ask you to find the value, it has to be geometric or this other kind. We aren't going to get to the other kind today. Okay, is that really geometric? How do I know? To get to the next term, you have to multiply by a common ratio. How would you get from 5 to 10? Multiply by what? 2. And this is 5 over 1. How would you get from 1 to 3? 2/3. Now, it's changing signs. I'm going to multiply by what? 2/3. Negative. So r is negative 2/3. I told you, it's a lot easier to do than getting through the explanation. What's the starting value? 5. Check. But they won't ask you for the sum unless you can do it. It's got to be geometric. So that's a clue. Pay attention to that. Does 2/3, if I take negative 2/3 times 10/3, do I get the next term? Sorry, it was negative 10/3. Yes, I get a positive 29ths. And you should just double check. Okay, there's the formula. All there is, S is equal to A over 1 minus R. You don't have to know that long, complicated formula for the partial sums, because we don't care. We only care about when they converge. Will this converge? That's your first question. Yes, because R is less than 1. It's a fraction. So S equals A, which is 5 over 1 minus R. So it's 1 minus a negative 2/3. If you have problems with fractions, this is the easiest way to do this. What am I going to multiply by, Justin? No, that's too hard. I want to get rid of fractions altogether. Well, I just multiply the denominator by 3 and the numerator by 3. I may have to reduce, but that's easier. What's 5 times 3? 15. And then, when I distribute this, I get 3 plus, and the 3's will cancel, 2. So the answer is 15 divided by 5 is 3. Now you might want to try to add those terms up on your calculator. If you have even if you don't have a CAS, if you have an 84, if you have the new operating system, you can put this in here. Yeah, you can borrow one, but you would have to actually add up the terms yourself. But I could actually do sigma. What would this look like as sigma? Now, they might ask you for the nth term. Okay, girls, they might ask you for the nth term. So what is this? What's A? 5. Remember, it's sigma A r to the n minus 1, where n starts at 1 and goes to infinity. And it's r, which is negative 2/3, to the n minus 1. N equals 1 to infinity. You could put that on your calculator, or your 84, and like start with n equals 1 to 10. And put that in there. You can do that if you want. And I could pull that negative 1 out and do this. And then it's 2/3 to the n minus 1. Let me change the index. Let's start at 0. Now I got to start with 5. So I want to do n equals 0 to infinity. So what's going to happen to the n? I want to get a positive 5. So if n equals 1, that will give me a positive 1, right? And this is negative 1, and this would be what? N equals 0. Just do it n. I'm shifting it down 1. You did that right? Doesn't matter, you can go the other way. What's this going to be? 2/3, and I want to get a 0 up here, don't I? It's just 5 by itself. So what does this have to be? To the n. So if I shift this a little bit, I just get something like that. The problem is recognizing them. I just write out the terms. Because I don't look at that and say, oh, that's geometric. If you see the exponential piece, that's this part right here, then it's geometric. Well, let's try another one. Ooh. I can't make it clear. I'll rewrite it so you can read it. It doesn't matter where you start, by the way. I know you're not used to it, but that's okay. This is 2 to the 2n, and then this is 3 to the 1 minus n. Is that exponential? Yeah, it is, actually. Now, we can do this the easy way, or we can do it the hard way, or we'll maybe do both. The easy way is just to put in n equal to 1 and write out terms. When n equals 1, what's the first term? It's 2 squared times 3 to the 0. So what is that? James, you need to do this with me, not pay attention. When n equals 2, let's write out terms. So then this is going to be 2. The 2n is 4 times 3 to the first power, right? So that's what? 60 times 3 is 48.
48.
Oh, did I do it wrong? No, 1 minus n? Oh, you're right. Because you know what? What was going to happen if that was doing what I'm doing? Would it converge or diverge? Or diverge. So this is what? 1/3, right? So this is 16/3. What if n equals 3? It's 2 to the what? 2 to the what? James. Justin. The door's there. This is not easy stuff. You will have problems with this assignment. Wait, 3 days. 2 to the 6th, and then it's 1, that's 3 to the what? When n equals 3, it's 3 to the negative 2, so it's 1/9. So let's list out the series. It's 4. Actually, I don't even want to write that way, because it's easier to see it this way. It's 2 squared plus 2 to the 4th times 1/3 plus 2 to the 6th times 1/3 squared. Anybody know what the next one's going to be? 2 to the what? 8th times 1/3 to the 3rd. What's the common ratio? Well, what's a? That's the easy part. There's your a. I'll show you another way to do it. And what's r equal to? You're going to multiply that by, how do you get the 2 to the 4th? You multiply by 2 squared. Does that work for this one too? Yes. So it's 2 squared, and you're going to multiply by what? Is it 3? Check. To get from here to here, it's 2 squared times 3. So what's the answer? It's what? 4/3. Does this converge? No.
So that's not the torque.
Yeah, does not converge. Right. Now, I want to do this a different way. I want to add a page because I want to show you how you can do it algebraically. This is what I call the brute force method. Just write out the terms. You don't mess up like me. Okay, so it's 2 to the 2n. 2 to the 2n, and it's 3 to the 1 minus n. Okay, that's really this. And it doesn't matter to me which way you do it. I think I did on my answers. Well, Mrs. Thurston did answers this time. It's 2 squared to the nth power. And 3 to the 1 minus n is 3 to the first power times 3 to the minus n. Is that correct? What do you do with exponents if the bases are the same? What do you do with exponents if they're the same? You just add them, right? So I could rewrite this, just like it's not right to write things without a limit, not right to write things without a summation sign. It's 2 squared to the nth power times 3. Let's just get that 3 out of there. Let's put it in front. And this is 3 to the n. Are you okay with that? I don't know which way is easier for you. But anyway, it's 3, summation n equals 1 to infinity. Well, that's 4 to the n over 3 to the n. I can rewrite that as 4/3 to the n. And there's your r, as long as you see that that's r. I didn't see it for the beginning. But anyway, r is greater than 1, so divergence. I like those.
That is easy.
Not always. You'll see some things. You'll see some things in the homework. You'll see some things in the homework. Now, oh, math team especially. Oh, no, see, you're not on math team. This one.
Can you go back?
Oh yeah, sorry.
I don't talk. Good for you, baby. I told my parents.
We could have used you. Although we have a great team. Matt, are you playing with your phone or sleeping? He's doing it. I don't remember who's on varsity. It's hard to make varsity. We got top-notch kids. Okay. Now, I'm going to do another, before I do the next problem. Ready? How do I know that 0.3 repeating is equal to 1/3? Let's do the easier one, actually. Okay. Well, what I'm going to do is let n equal 0.3 repeating. I'll write up a number of the digits out. And then I'm going to multiply it by 10. So 10 times n is 3.3 repeating. And then there's a little trick. Mathematicians and all their little tricks. I'm going to minus this and add. What's 10n minus 1n? 9n is equal to, and what's going to happen to all of this stuff? It goes away. Well, provided we get to infinity at the same time, and that's for an upper level math class. And you divide by 9, you get n equals 3/9 or 1/3. Okay, that's the easy way to do this. We're going to write this as a geometric series that show it's 1/3. Now I haven't practiced the other one either, so I don't know what I'm talking about. Okay, so example. Write this as a geometric series. Well, this is 0.3 plus 0.03 plus 0.003, right? Etc. And I'm going to write it as a fraction. So this is 3/10 plus 3/100 plus 3/1000 plus 3/10,000, right? What's the common ratio? You're multiplying by 1/10. What's your A value? 3/10. So S is equal to A over 1 minus R. I hope it works. It has to work, doesn't it? That's what I like about math. It has to work. So it's A, which is 3/10. And you can do 1 minus 1/10, which is 9/10. Wait, I forgot my 3/10. That was okay. 3/10 is 0.3 or 3/10, and this is 9/10. And how do you get rid of decimals here? Multiply numerator and denominator by 10 over 10, and that's 3/9 or 1/3. So you can change a repeating decimal into a geometric series. I picked an easy one to start. Let's try the next one. Where is that? This way? Where is it? No, that's going too far. Oh, wait, it's back here. There it is. Can't because it's not repeating. Okay, what is this? This is 2.3 plus 0.0171717. Do I have my decimal in the right place? I think I do. What I'm going to do, the 2.3 is irrelevant. This is the piece I want to write as an infinite series. I just think it's kind of cool. I'm trying to think if they have it on the exam. Okay, So it's 17 over, you guys know how to get the place value the easy way? It's 1, 2, 3. So it's 1 followed by 3 zeros. I'll put that in years, but anyway. And then it's going to be this one, plus 17, 1, 2, 3, 4, 5 zeros. Plus, anybody have a guess? 7 zeros. And you know what the repeat is? 4, 5, 6, 7. The repeat is 2 decimal places. So it's R equal to 1 over 100. My A value is this. We're just going to add a 2.3 in later. It's irrelevant. All I want to do is take the repeating part and write it as a geometric series. So A is 0.017 or 17 over 1,000. I don't care. Okay. S equals A, 0.017 over 1 minus 100. Minus 0.01. So S equals 0.017. What's 1 minus 100? 1 minus 100? 0.99, right? Now, I want to get all the decimals out here. This is what I'm saying math thing. This is a typical math thing kind of problem. Multiply not by 100, but by 1,000. So I'm going to get 17 over 990, right? So it's 2.3. So my answer is going to be 2.3. So it's 2 3/10 plus 17 over 990. Do you think I care if you can add that up? No. Your Inspire calculator will do it for you. I'll give you a simplified answer. Well, I would multiply the first fraction by, it's really this, 99, right? If you want to do it. And then you can do all the arithmetic, right? Well, what's the easy way to do 3 times 99? Well, I'm here. What's 99 close to? Right. That's 300, but I'm 1 short. So 300 minus 3 is 297, right? Over 990, and who cares? The rest is arithmetic. Because on the free response part of the exam, you wouldn't have to worry about it. Multiple choice, it would never make it that complicated. I don't think. Because that's arithmetic. Okay, so there's only one other thing you need to know. We'll talk about it more tomorrow. But if you're adding up an infinite series, so you're doing a sub 1 plus a sub 2 plus a sub 3. Now you have to think for a moment. A sub n. If you want that to converge, because I think you need this in the homework. If you want that to converge, what has to be true about the nth term of your sequence, the limiting value? How small? It's got to be what value? You're right. It has to be 0. Because if this term you keep adding up here is not 0, what's going to happen to your series? It's going to grow. So, for a series to converge, we now have our first 2 tests, convergence tests. The limit of the nth term of the sequence as n goes to infinity must be 0. Now this is a theorem. Are you allowed to reverse a theorem? What if the limit of a sub n is 0? Does the series have to converge? That's the tricky part. If we know that the limit of a sub n equals 0 as n goes to infinity, this is your favorite expression. I know nothing. I know nothing. Good if it applied. I know nothing. There are 10 tests. The first test you always do is check to see if this is 0. If it's not 0, you're done. Diverges. If it is 0, you're not done. You go to the next test. The next test is look to see if it's geometric. You have 2 out of 10 done. A3 will be picking up a whole bunch more. There are 10 convergence tests. And I have the 10 days of convergence up on my website, probably someplace. I could print it out. I did it to the 12 days of Christmas. Whatever works to help you remember it. Yes, but, Nat, you take the limit of the sequence. If it's 0, nothing more to do. Not 0, nothing more to do. What about the harmonic ones? You remember the harmonic sequence? Now, what's a series? Hey, guys, what's a series? You add up the terms in the sequence. The harmonic one looks like it's 1 over n. What's the limit of 1 over n as n goes to infinity? Now, you're going to have to keep things straight. Doing a limit of a sequence is pretty straightforward. Just find the limit of the sequence. Don't get it confused with series. This is 0. But guess what? This one diverges. Sorry. What about this one? 1 over n squared. And I'll prove this to you if you want me to. The limit of this one as n goes to infinity, 1 over n squared, does equal 0. This converges. So the problem is, just because the limit of the sequence is 0 doesn't mean you know the series converges or diverges. It just has to be 0 for that to happen. This is what's happening is these terms are getting to 0 really fast. This is not getting to 0 fast enough. So later on, you do keep adding on, even though it doesn't look like you're going to be adding something on. You are. It's an interesting problem. Now, did you have questions on some of the homework problems? Worksheet or the book problems? I thought I did a lot of them on Wednesday. Always just help yourself. Where's my other book? Oh, there it is. That's how everybody's felt today, and I've done a lot today. But we spent 3 days on this. Tomorrow, we'll review it. We'll do collapsing sums, hit on geometric series again. 8-1 questions, worksheet. Oh, on the worksheet, I posted those. I redid it because my worksheet was different than my original worksheet, so the author must have changed this. Okay, I want to know the limit of that sequence. Okay, James, what did you do with this problem?
I would calculate.
Well, why don't we write out some terms? What's A1? Is equal to -1 to the first power. Then it's the sine of pi over 2 times 3. What's the sine of 3 pi over 2? -1. So this is -1 times -1, which is 1. What about A2? It's -1 squared. It's the sine of pi over 2 times 5, right? What's the sine of 5 pi over 2? 1. You want me to draw the picture?
Nope, we got it.
So that's 1 times 1, which is 1. A3. I would do the same thing with the one before it. I thought I was doing it wrong because the problem had been changed from the original problem I did. The A cubed, this is the sine of 7 pi over 2. Well, so it's -1. Well, what's the sine of 7 pi over 2? -1. So even though it looks kind of strange, what does this converge to? 1. I don't know what to do, write out some terms. And I had to do that with the preceding one.
So they're good for or is it just multiple choice?
What's going to be, mostly this will be multiple choice. The FRQs will involve some things that we have to do later on that we don't know. And we use all our convergence tests to work on specific instances in our summation. But most of the time it's pretty easy. Most of the time it's pretty easy. You're looking for geometric, and you're also looking for the 1 over n, the harmonic series. You'll see when we get there. I know it's hard to know where you're going with this. That's the first half of Chapter 8. The second half of Chapter 8 is to go beyond linear approximations for a function. We'll make them stronger. This is only first half, doing the convergence test. I need those to do the second half of chapter 8. That's the reason why we do them this way. It's fun. Now, keep in mind to work on your little study packet. But don't put that off to the very end. That you have a study guide in there. I think it's pink. Man, aren't you glad? Don't you wish you were here last week?
He was skipping. He was playing hooky.
So I'll be here tomorrow morning, but I just did implicit differentiation with AB. Yeah, yeah.